Okay, I want to illustrate some of the new rules we have in finding a derivative. And remember that we used to find a derivative by using our limit definition. But notice also when we did that, although it was very cumbersome, we ended up with some very nice patterns of cancellation. And recognizing those patterns, the author has come up with some rules that we can use to shortcut that. The derivative is still based on that limit definition, but the rules are shortcuts to calculate that limit without going through the four-step process that we were doing. And for this polynomial here, to find the derivative, or f prime of x function, I'm going to use the power rule and properties of derivatives, that the derivative of a sum is the sum of the derivatives. I can take the derivative term by term. I'm going to multiply according to the power rule, bring the 4 down, multiply it by the minus 7 to get a minus 28, and then drop the power by 1. 3 times 5 is 15, drop the power by 1. Minus 2x, x is to the first power, so I'd have a minus 2 times 1, and then drop the power by 1, and also we saw that the derivative of a constant was 0. So I'll go ahead and simplify this. This would be minus 28x cubed plus 15x squared minus 2 would be my derivative. This also works with fractional exponents. Suppose I had something like minus 2 over the square root of x. First thing I would do there is to rewrite that as minus 2x to the minus 1/2. Remember that the square root is the 1/2 power. And writing this, it's in the denominator, so writing it as minus 2x to the minus 1/2 puts it in a form that I can apply the power rule with. And again, even on fractions, this rule works. Minus 2 times a minus 1/2 would be 1, and then I would subtract 1 from the exponent, which would leave me with x to the minus 3/2, or f prime of x is equal to 1 over x to the 3/2. Or actually, I could write that back in radical form. If you remember, I would have the square root of x cubed, and then if you wanted to simplify that further, I could pull out, or square root out an x squared, if you will, and write it that way. Now, there's other forms that we can work on algebraically before we take the derivative. Suppose I had 3x squared minus 4x plus 2 over x. Now, what would I do there? Again, like a lot of these, I'm going to try to write it in a form that I can apply the new rule I have, the power rule, and some of the properties. And if you remember, I'm dividing here by a one-term x, so I could rewrite this as 3x squared over x minus 4x over x. I can take x into each term in the numerator, and then I can write my function as 3x minus 4 plus 2 times x to the minus 1. And that gets me in the form that I can apply my power rule. So I have 3, and then minus 4, the derivative of that would be 0, and then minus 2x to the minus 1, subtract 1 would be minus 2, or finally my derivative would be 3 minus 2 over x squared. So the first thing to do is to realize what the rules are and the properties we have, but then when you get a problem in this section, some of them you're going to have to manipulate algebraically to get them in the right form before you apply those rules.